Hey y'all, it's me, Miss B. Today we're talking about right triangle trig, and so we're evaluating trigonometric functions. Okay, so we're gonna just kind of speed through this bell ringer. It should be reviewed from our unit circle in some way. So notice that I switched the one to this side right here. Go ahead and make that change on your own paper. So we want to find the missing side lengths using trig identities. So this trig identity, we should know that the hypotenuse is twice the length of that side. And this side is radical 3 times that side. So we get radical 3 there. Good way to test is to do one side a squared plus b squared equals c squared. You get 1 plus 3 equals 4. That's true, so we know we did it correctly. This one here, got 45, 45, 90. These sides are going to be the same solely because of those angles being the same. So then this last side is radical 2. And lastly, this one's just sideways of 30, so we get radical 3 and 2 for those two sides. Okay, here I want to talk about maybe this triangle first. So if this is my theta right here, my opposite side is going to be the one that's exactly across from theta. It's kind of a terrible arrow. So the one that's directly across from theta is my angle. The one that's across from my right triangle is my hypotenuse. So this is my hypotenuse, this is my opposite side. Okay, and then the leftover one is the adjacent one. It's the one that's next to the angle. That is not the hypotenuse. Let's go ahead and run through these. So, sine of theta is going to be opposite over hypotenuse. Just always true. That's what the so is. Ka means adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? Cosecant, secant, and cotangent are the inverses of those. So if we had opposite over hypotenuse for sine, then cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over hypotenuse. Okay, so we want to fill out this chart down here using our bell ringer. So I'm going to go over the first one with you. I'm going to take this triangle to solve this one here. So I have my 30 degrees triangle, and I want sine. So my opposite over my hypotenuse, which is 2. So I have 1 over 2 for that one. Cosine is going to be my adjacent side over my hypotenuse. So radical 3 over 2. Sorry, I accidentally erased that. Radical 3 over 2. Then my tangent is opposite over adjacent. So 1 over radical 3. We don't like to leave radicals in the denominator, so we're going to multiply by radical 3 over radical 3. So we get radical 3 over 3 as that angle. Go ahead and do the next two. For 45, you should have said sine of 45 is radical 2 over 2, cosine radical 2 over 2, and tangent 1. For 60, you should have got sine of 60 is radical 3 over 2, and cosine of 60 is 1/2, and tangent is radical 3. Now I want to talk about Pythagorean triples. These are going to show up pretty often. So I'm going to show you the first one here. Basically, these are Pythagorean triples are triples that, or let's call them triangle ratios that often show up. That's true for whatever reason. Okay, so for this one, I have 3 squared plus 4 squared equals something squared. We'll just call it x. So I have 9 plus 16 equals x squared. 25 equals x squared. So then x is equal to 5. So 3, 4, 5 is our first one. And what that means is it's a ratio. So it could be a lot of different things. If I were to take each of these and say 6, 8, 10, just multiply them all by 2, that's still a 3, 4, 5 triangle. Same thing if I do 3. So 9, 12, 15. Okay, so those are just ratios that are going to often show up. Our other ones are 5, 12, 13, 7, 24, 25, 8, 15, 17, and 9, 40, 41. Getting more, less and less common as you move from left to right. Okay. So here I have an example. Given that theta is acute and cosine is 3 over 4, find the other 5 trig ratios. I'm going to draw a triangle. That's the best way to go about this problem. So theta is acute. That's helpful because it's not always. And cosine, so adjacent over the hypotenuse, is 3 over 4. So adjacent is 3 and hypotenuse is 4. This is just the ratios. So then I have that this last side is going to be a squared plus b squared equals c squared. So then I'm going to do 3 squared plus b squared equals 4 squared. What I do end up getting is that b is equal to radical 7, and we'll just leave it like that. Okay, so we get b is equal to radical 7. Sine of theta, so our opposite over hypotenuse is radical 7 over 4. Cosine, given to us, 3 over 4. Tangent, radical 7 over 3. Now we want to flip each of these, so I get 4 over radical 7. No radicals in the denominator, so multiply by radical 7 over radical 7 to get 4 radical 7 in the numerator, and then radical 7 times radical 7 is just 7. Doesn't simplify down anymore. Secant, flip that fraction, we get 4 over 3, and then tangent, 3 over radical 7. Got to simplify that, and so we get 3 radical 7 over 7. Alright, this is just a note that mode matters here. So if we were to go, I'm going to go to our calculator. So if I were to type in cosine, actually, let me go flip it this way. So if I were to go to my mode, and yours maybe looks a little different than mine, but you're going to go to your angle unit, and I'm going to put it into radians because that's what it's in right now. So if I say cosine of 45, that's without the degrees. Sorry. There we go. Cosine of 45 is 0.5253. But now we want to find it in degrees. So if there's no degree sign, it means we're in radians, but we want to put it back to degrees. So we're going to get a mode, radian to degrees. and then I'm going to do cosine of 45 on there. Notice that these two things are different, so we got 0.7071. So that means we have to make sure we are in the correct calculator mode. So for cosecant of 100, we don't have a cosecant button on our calculator, but we do have a sine button. We know that cosecant is 1 over sine. So 1 over sine of 100 is cosecant. So we'll type 1 over that in our calculator. So I have my calculator in degrees. So 1 divided by sine of 100 gives me 1.0154. 1.0154 for that answer. Okay, sine inverse and 1 over sine of theta are not the same thing. Okay, this means something completely different. Let's do one example together. So, siting the top of a building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. First, let's draw a picture. So, here, we've got, this is our surveyor. He's looking at the top of the building, and it's looking to be 22 degrees. Where he's standing is 5 feet above the ground. And he's also 300 feet from the building. And we want to find the height of the building. So we're going to need to find this and then add 5 to it. So let's go ahead and find this height right here. We're going to call that x. You'll notice that we have the opposite side and the adjacent side. There's only one equation that uses opposite and adjacent, and that is tangent. So we're going to say tangent of 22 degrees is equal to x over 300. To solve for x, I'm going to multiply both sides by 300 and type that into my calculator. So I'm going to have 300 times tangent of 22, and that's in degrees. So 121.21. And that is feet. But that's not what it's asking for. It's asking for the height of the building. So we have to take 121.21 plus 5 to get our height of the building is 126.21 feet as our total height of the building. Okay, that's all for today, folks.